Hello everyone. In this presentation, I will show you an experimental attack that I performed on my UTXO token system to show you how to tackle some vulnerabilities of the back to Genesis issue. First of all, tokens that are not native of a given blockchain are considered secondary issuance tokens. In UTXO blockchains such as Bitcoin, the value of the native UTXO token is the self-same satoshis it backs. So if you have an address and that address has some satoshi, the satoshis represent the value of that address and all the UTXOs of that address. But when we have a secondary issuance token, the value of that token lies in the script and not on the satoshis it's back. I'll show you why. Then, if we can disguise a secondary issue UTXO script, the token system can be broken. So to strengthen the token system, the token system must not allow the creation of tokens with different script templates, and this can be solved using stateful scripts, and also the system cannot allow users to replay the tokens UTXOs. So the adversary, his job is to try to disguise an UTXO and bring it back to the main chain that is created by the issue, and his disguised UTXOs will not be tied to the issue Genesis transaction. So now we have an scheme of what we'll do here. We will issue the token, transfer it to the user, and the user will propagate it on the chain, and one of them will try to disguise a token and bring it back to the system. First, we create this token with 10 units. Here is the first operation done by the issuer. These operations can be done here on our website. You can come here and put some private key that you have, and you can use testnet or mainnet or wherever, compressed or uncompressed format address, and you can come here and smart contracts. And in this first example, we are working with the basic GP token, and we have here the token with all these functionalities, and this is the creation of the token. So we come here and create a token with 10 units first. You can use this TXID to search it on the blockchain, and you also can use this TXID to view, to watch the characteristics of the token, to consult its detail here on our site. You just put the TXID here and short reach, and it will bring all the characteristics of the token. And now we will transfer some units to Alice. Now the issue put in circulation 4 units to Alice, and now Alice transfer 1 unit to Bob. Alice now has 3 units and Bob has 1 unit. Bob will now create a disguised UTXO of his token. He has control over that token, so he can create that. To create that, I created this system here in Didactic, and you can come here and replay UTXO. You put the number of satoshis of that UTXO, you place here the UTXO script, or you can place it by selecting a file where your script is in text file, text format, and in hexadecimal format, and you can replay that UTXO. Bob did that and created this new transaction here. Now Bob has two UTXO, and one is very suspect because its input has not the characteristics of a regular token from the honest chain, from the original token chain. But Bob can wash that transaction, that format of the token, transferring it first to himself and then trying to transfer to another users, or do any other operation that the token system allows, and it can try to bring it back to the chain. Now he will execute a merge of these units. He has one unit here, one unit here, and he can use here our feature of merge, and can merge those units in one single UTXO. And now this UTXO has the same characteristics of a regular transaction of the token chain. This done, Bob has compromised the token system if he's able to insert that unit back into the original chain, if he finds a backdoor in the token security, in the token system. And now the issue is still have 6 units of the original 10 units. Alice has 3 units. Bob now has 2 units. The issue created 10 units. He issued 4 units, and now we have 5 units circulating, and the token system is compromised. Now to tackle this issue, we built this solution using an oracle that will sign the transaction when the user try to use that transaction, and he will verify the transaction, and if the transaction is okay, if it's honest transaction, the oracle will sign, and the user also will sign, and can be put into the token system. Otherwise, it will not be allowed. So here is our UTXO scheme. So now we have the oracle signature, and the issue controls that oracle. The issue has all the responsibility over the oracle. Now let's do the same steps we did before, but now we do the steps using this token, this version of GP token with Oracle ECDSA hard. I will explain to you in another opportunity, and it has all the functionalities of the basic GP token. Now we create with the same 10 units. We issue some units to Alice. Alice transfer 1 unit to Bob, as in the previous case. And now Bob tries to replay that UTXO, and he can create that new UTXO from his original UTXO. However, the script of that token will not allow any operation, any critical operation for that token. So when Bob tries, for example, to merge those units, it will not be allowed, so he cannot propagate that UTXO into the token system. If he tries to wash that transaction, transferring it to himself, it will not be allowed. Actually, in the proposition of my solution, the only transaction that is allowed for Bob to do is to extinguish the token, because he cannot put it into the token system. He can create and he can extinguish that token, but that is the only operation that he can do. He cannot bring it, he cannot transfer it to other user. He can do nothing with that UTXO. It's just useless. So the token system is preserved. It's very resilient, using this Oracle scheme, and the tokens, the original units, number of units was created is 10, and we have put 4 in circulation, and we continue with only 4 units in circulation. So here are our different versions of the GP token that I presented to you in this video. And here we have some features that we can observe in our tokens, in the script of our tokens. The main thing here, besides the other, is the size of the script. The basic script of GP token is 31 kilobytes. If we use a soft ECDSA Oracle, we have 35.7 kilobytes. If you use Raven Oracle, we use 37.4 kilobytes. And if we use hard ECDSA Oracle, we have a 56 kilobytes script. The difference between the hard and the soft is that in the hard Oracle, the Oracle always signs the transaction with a different key, with a different private key, whereas in the soft ECDSA Oracle, it always signs with the same private key. The Raven always uses a single private key, as in the soft ECDSA Oracle. So this is our solution to tackle replay UTXO in the UTXO token systems using this Oracle approach. So see you next time. May God bless you all.